Today we will learn about inverters, compressors, defects. We are going to cover in this. We start with the taking feedback from the customer, ask questions from the customers, prepare a dot matrix chart, understand the type of failures and diagnosis steps, followed by the process of diagnosis, and then finally the repairing of those defects. First of all, we take feedback from the customer. Customer may say that outdoor fan is working, but the compressor is not working. The customer may give a feedback like there is no cooling in the air conditioner. There may be some errors which is specific to the respective models, which is displays on the indoor unit. Some questions which is to be asked to the customer to better understand and which relates to the symptoms are: at which mode AC is running? This question is asked to understand whether compressor is working or not due to selection of the wrong mode. Is the outdoor fan is working? This question is asked to confirm the status of the electrical supply to outdoor unit. Is there any intermediate cooling in air conditioners? This is to confirm the availability of refrigerant and working of outdoor unit. Is there any error display on indoor unit? This will confirm the respective defect related to particular error. Is light fluctuate when you on the air conditioners? This is to identify the condition of the electrical wiring connections to the air conditioner. Now we prepare a dot matrix for inverter compressor defect. The defects which will be considered is low voltage, loose connection, audio is outdoor unit PCB not working, ambient temperature across outdoor unit, compressors electrical defects like open, short, ground, compressors mechanical defects like jam. Now we understand the possibility of failures under different types like compressor electrical defects, open, short and ground, low voltage and or loose connections comes under electrical type of defects. Audio PCB not working comes under electronics types of defect. Compressors mechanical defects like jam is a mechanical nature of defect. Ambient temperature across outdoor unit is under environmental conditions. Now some of the parameters which is to be checked, like in case of low voltage we have to check the voltage. If the voltage is proper, then there is no action required. If there is a problem in the voltage, we have to educate the customer to correct the voltage and recommend to use the voltage stabilizer. In case of loose connections, first of all we have to ensure the firmness of the connections, and if there is a problem in the connection, we have to tighten the connections. In case of outdoor unit PCB not working, we have to check the outdoor unit PCB and its output to the outdoor unit. If the PCB is okay, then there is no actions is required. If there is a problem, we have to replace the outdoor unit PCB. In case of ambient temperature across the ODU unit, we have to measure the temperature. If the temperature is as per the specification given, then there is no action required. In case there is a increase there is in the temperature, then we have to instruct the customers to cover the outdoor unit from the top in order to avoid direct sunlight on the unit. In case of compressor electrical defect, we have to check the compressor for short, open and ground windings. If it is okay, then there is no actions needed. In case there is a problem, we have to replace the compressor. In case of compressor's mechanical defect, we have to first check the compressor for jamming. If it is okay, then no action is required. If there is a problem, then in that case also we have to replace the compressor. Some of the tools which are required to carry out this inverter compressors checking process is reversible screwdriver, digital multimeter with capacitance testing facility, and a manifold gauge. First of all, we have to ensure that the supply given to the inverter air conditioner is proper. For that, we have to check the power supply condition. We have to check the power plug. We have to ensure that the phase should be at right and also confirm the availability of earthing. The voltage between neutral and line should be around 230 plus minus 10 percentage, and the same voltage should be available in between earthing and phase, and in between neutral and earth there should be no voltage, like 0 volt between neutral and earth. For that we have to use a proper multimeter to ensure the availability of voltage across the terminals. After checking, we have to ensure that voltage between neutral and phase is 230 volts. Voltage between phase and earth should also be 230 volts, and voltage between neutral and earth should be 0 to volt. Defects. Now we start with the defects. In case of low voltage, we have to check the drop in the voltage during compressor start. If the voltage drop below 180 volt, then there is a chance of neutral weak, which may be lead to the compressor tripping. So here we have to note that the minimum starting stable voltage for compressor is 200 volt. We will check the outdoor PCB not working defect. In that case, we have to ensure that the PCB is giving output that we can check with the help of a test jack. We will connect the UVW terminals with the test jack. There is a small video by which we will understand how we can connect the outdoor unit PCB, and the inverter checker will help us to identify the PCB working condition. We can check the inverter compressor and IPM with a with a light bulb. There's a small video which will help us to learn about how to connect the bulb with the respective PCB and compressor. Final connections of the test kit. One end is free and the other one is insulated with the tape. Then we identify the UVW terminal at PCB and the compressor junction. Third, free wires of bulb into the U, V and W terminal. If PCB is okay, it produces output signal and all three bulbs will glow. We will visually inspect the PCB by uh, checking is there any burn marks of the components in the PCB. Now we will go with the another defect of ambient temperature across ODU unit. We have to check the ambient temperature across the ODU's outdoor unit. We have to ensure that the outdoor unit is not exposed to the direct sunlight. Always cover it from the top. As we know that the direct sunlight on outdoor unit will increase the temperature by 30 degrees centigrade in addition to the current ambient temperature. Increase in temperature will increase the compressor head pressure, which lead to the compressor tripping. Now we effect of loose connections. We will ensure that the wires are properly connected to the terminals. The defects which arises due to loose connections are high power consumption, terminals overheated due to loose connections, electric shocks, intermittent failures. How we have to check the loose connection? We have to visually inspect, check the firmness of the connections. We have to check the resistance or continuity of wires or joints. Check the joint between the wires. Proper size of the connectors will be used to avoid loose connection. We have to ensure the firmness of the connection, that the wires are properly tightened. To check the resistance and continuity of connections. In case of variable speed, the three terminals on the compressors are known as U, V and W. We will test for short winding of the compressor. We will test for the short winding of the compressor. We check each and every three terminals. In case of variable speed or inverter compressor, in each pair there should be a continuity or equal resistance value. pair there should be a continuity and a finite resistance value. If the resistance value is showing 0 in between any two windings, the windings are short. Now we test for open winding. We have to keep the knob of the clamp meter or a multimeter in the continuity or lowest resistance reading. We have to check the continuity between each pair of three terminals on the compressor. We have to ensure that the clamp meter's probes have a good contacts with the terminal. In each pair, there should be a continuity and a finite resistance value. If in any pair of the terminals there is no continuity or clamp meter is showing 0L or 1, the winding is open. Now we test the compressor for ground. We have to keep the clamp meter or multimeter in a continuity or a lowest resistance reading. Check the continuity of each terminal one by one with the body of the compressor. While checking, we have to ensure that the probes of the multimeter has proper contacts with the ground and the compressor's terminal. This testing method is same for both fixed speed and variable speed compressor. As you see that we are checking the terminals with the ground, with the body of the compressor. We have to keep the knob of the clamp meter or multimeter in the highest resistance position. Each terminal we have to check one by one with the body of the compressor. While checking, we have to ensure that the prop of the multimeters has a proper contact with the ground and the compressor terminal. If the multimeter shows OL or 1 in the highest resistance range also, this testing method is same for both fixed and variable speed compressor. If there is a continuity between any of the terminals and the body of the compressor or any finite value shown at the highest resistance values also, the compressor winding is ground. Now the testing for the loose contacts at the compressor terminals. There's a symptoms of intermittent starting issues. Sometimes compressor may not get started because of the loose connections of the wires at the compressor's terminal. We have to check for any loose connections or carbon or rust formations on the wires and the compressor terminal joints. Now we mechanically test the compressor. These tests are hot tests that is to be carried out during the running condition. Means the compressor is running, in that case, in that condition we have to check. There are two parameters which is to be monitored during the mechanical test. One is ampere reading, another is suction pressure. In case of jam, the symptom is of no cooling. We have to check if the compressor is getting tripped after running some time. We have to check the temperature of the dome of the compressor. In compressor jam case, it will shows abnormal high temperature. We have to check the ampere. If the ampere is getting high, 4 to 5 times then the rated, the compressor is getting tripped. Sometimes creates abnormal noise while. Thank you.